This is the first problem of 2019 Combined Maths A-Level paper. So we are given this problem to prove using principle of mathematical induction. As usual, this is the first problem. Now, when you answer this question, I'd like to look at this in 3 steps. So the 3 steps that we do is, first one, you have to show that this result is true for n equals 1. Second step would be to assume any general integer, say n equals k, and assume at this n equals k the same result given here is true. And third step would be to show that the result will be true for n equals k plus 1. These 3 steps is what you need to prove this statement using mathematical induction. Now in A-Level, to earn all the points you have to get, you kind of have to think about this as a 4-step process. After you are done with all these 3, you have to write in words the statement that result is true using mathematical induction. So let's look how we proceed from here. So showing that this is true for n equals 1 is the first step. Let's see whether this is actually true. So left hand side LHS, when n equals 1, you will get r goes from 1 to just 1, which means we only have one term. When r equals 1, you get 2 times 1 minus 1, which is equal to 1. And since the summation does not go beyond 1, you only have one term, which is this one. And that's the left hand side. The right hand side of the statement, when n equals 1, would be just plugging in 1 for n squared, which means you get 1 squared, that is just 1. And this shows us the left hand side equals to the right hand side. So we have just shown that the result is true for n equals 1. And now the next step. The next step is to show or assume the result is true for n equals k. So with this assumption, what I can write is, I can say if I have r going from 1 to k, because my n is k now, this n is k now, so when r goes from 1 to k, 2r minus 1 should be equal to, if the result is true, it should be equal to n squared now will be k squared. Remember, our n is k now. So I assume this is true. Now comes the third step. The second step has nothing much. You just have to assume that this result is true for some value of n. Now comes the third step. Let's see how we go from here. So as the third step, we have to show for n equals k plus 1, the result is true. Now the left hand side in this case would be r goes from 1 to k plus 1 to r minus 1. Now what will this be? Since I have made an assumption, which I have here, I can write this sum, which goes from r from 1 to k plus 1, as a sum of this result on the left side plus another term. So what does that mean? If I just let this go from 1 to k, then that will take care of the first k terms of this form, but there will be an additional term. Plus 1 gives us an additional term of this form on the left side. So how do I account for that? On the left side, I have from 1 to k of 2r minus 1, but the k plus 1 term, this only takes care of up to k. So what is the k plus 1 term? This adds to k plus 1 term. That will be 2 times r will be k plus 1, and then you have a, that's just r. 2 times r will be k plus 1, and then you have a minus 1. So minus 1, that gives us the k plus 1 term. Now we can simplify this a little. I know this term equals k squared, so everything here can be replaced with k squared, and then I have plus 2k plus 1 minus 1. And if I simplify this as this one, as I write 2k plus 2, then minus 1 makes it just 1. So 2k plus 2, then 2 minus 1 would make it plus 1. That's what I get. Now what is my goal? If the result we had is true for n equals k plus 1, on the right side I should have k plus 1 squared. So by showing that n equals k plus 1 gives us the result, what we mean is, if I write it in this color, that when the left hand side goes from 1 to k plus 1 of 2r minus 1, following the given formula, when it is just n on the top, we have n squared on the right side. So if I have k plus 1 squared, I should be good. So what I'm trying to show that this is true. Now let's see if this part here is actually that. What do you think? Now this one is actually k plus 1 squared. This needs some factoring. You have k squared plus 2k plus 1. That means 1 times 1 is 1, but 1 plus 1 is 2. So you see it nicely factors out to give us k plus 1 squared. And that proves the result that statement is true for n equals k plus 1 when you assume it to be true for n equals k. So this actually completes the proof using induction, but this is A level we are talking about. So to get all your points, you have to finally write that by using mathematical induction or by using principle of mathematical induction, the statement is true. And that is the first problem of the combined math paper for 2019.